All right, last section from chapter 5, section 1. We're going to be doing compound interest, and I'm going to go into a little bit more detail about the constant E. All right, so on this page we have the true definition of E, right? So this definition that you see right here with the limit, the lim, n approaches infinity, this is the true definition of E, and you see this in detail in like calculus classes, right? But I'll explain a little bit more about what that means in a second. But first, I want to go over this formula right here, the one that says A equals P times 1 plus R over N to the NT, right? So this is for if you have some money problems or word problems, right? So that's what this section is on. You're going to have word problems. And the ones in these notes are pretty simple, right? We don't really give you too much context or anything, right? But I believe in WebAssign, you have some problems that tell you like certain scenarios. They give you like real scenarios where this could apply, right? And I told you guys from the beginning that exponential functions are especially useful when modeling trends with money. So if you know how, for example, a credit card works, a credit card, you're essentially borrowing money from a bank, a lender, and you have to agree to pay it back in a certain amount of time, right? So let's say I borrow, I don't know, $1,000 from the bank using a credit card. Now, you don't have to pay off the $1,000 right away, right? So typically there's some minimum payment that you have to pay, and as long as you make this minimum payment, you don't have to pay off the entire thing, right? But in order to, I don't know, to kind of establish some trust with the borrower, aka you, right, the person that's borrowing this $1,000 that you spent, to establish some trust, they charge you some interest, right? Interest is going to be, right, the rate, right? And you'll see like in some problems they'll say like it has an interest rate or like an APR, right? So they charge you some interest, and that's just a little bit extra on top of what you originally borrowed, if you didn't pay it off in a certain amount of time, right? You can pay off your credit card in that same month, right, and not have to pay any interest, right? But the longer that you put off paying off the entire thing, then you end up paying a little bit more. So let's say your credit card has 20% interest. You, in a year, are going to end up paying, assuming you don't change the amount of money that you borrowed, are going to end up paying 20% more than what you paid a year ago, right? But credit card payments are typically due in monthly increments, right? So there are how many months? 12 months in a year, right? So that means in a year you should expect to make 12 payments, right? But that doesn't mean in each of those 12 months it's going to be 20% more than what you borrowed, right? That's going to accumulate a lot of money, right? But it's going to be the rate divided by that 12, right? That's where this part of the formula comes from, right? The rate divided by 12, right? And this time we're compounding the interest 12 times, which means that you're not going to be paying 20% more in that 1 month. You're going to be paying 20 divided by 12, which is about, I think, 1.67, right? So after each month, you're going to be paying 1.6% more than what you originally borrowed, right? But that's just going to keep building over the course of those 12 months, right? So every month that passes is going to be another 1.6% until you reach that year of that gives you the full 20%, right? So you end up paying a little bit more than 20% of your whole originally borrowed money, right? Like a couple dollars more, right? Assuming you don't pay off the whole thing. And so the idea of this is that if you keep compounding your money, right? Compounding just means it's like interest on top of interest, right? So it's not you're not collecting interest over just 1 year, it's over increments, right? If you have monthly increments or maybe weekly increments, right? Maybe you have 52 increments, or daily increments, right? 365, right? This n right here would be 365. The more you do it, it's not like you're going to get an infinite amount of money or you're going to have to owe an infinite amount of money. It approaches a number, right? And that number is this number right here, E, right? Now, in class, I had given you guys an example of if you borrow $1 from me, like let's say you guys want to ask me for $1, that your principal value is going to be 1, right? And let's say I'm a very generous lender and I let you borrow at a 100% interest rate. That's going to be 1 as a decimal. And then I keep compounding it, right? The more you compound it, right? So in a year, if I didn't compound it at all, you'd owe me only $1 extra, right? 100% of 1 is 1, right? So on top of that, you'd end up owing me $2, right? But if you split it up, like let's say after 6 months, I ask you for half of that dollar back, right? You pay me $1.50, but you need to fulfill that 100%, you would pay me another 50% on top of that. So another 75 cents. And then you end up paying me a little bit more money, right? But if you keep doing this forever and ever, now I had shown you guys in a calculator, right? And you guys can mess around with this too, right? If you plug in really big numbers here for n, as long as they're the same thing, right? So if you plug in like 100 for n, if you plug in 1,000, if you plug in 10,000 for n, as long as they're the same number, you'll approach this number right here, 2.718. And if you type in E in your calculator, you will get this number. You'll get the exact value of E, right? So that's where this number E comes from. And you're going to see in the next page that when you do these problems, that the more times you compound in a year, you'll get a little bit more money. All right, so let's try some examples now, right? I know I did a lot of talking, right? But let's put this into practice, right? So our formula that we use in this section is P times 1 plus R over N to the NT. All right, so I'm going to go ahead and label everything that I have, right? So I have my principal amount is the amount that we invest. So we invested $12,000, right? The annual rate, the rate should be written as a decimal. So I'm going to say my R equals 3% as a decimal is 0.03. All right, find the balance after 5 years. So if I want to find 5 years, 5 years is T equals 5, right? Your time is always going to be written in years. Compounded quarterly, right? So quarterly, right? Every quarter of a year is going to be 3 months. Now, how many 3-month increments do you have in a year? Is going to be 4, right? And you can even just think of the word quarterly, right? Quarterly means that you split it into 4 parts. So that means n here is going to equal 4. So I'm going to take all of these values and I'm going to plug it into this formula. Remember, this is going to equal A. A is your accumulated value, or the value that you get in the future, right? After the 5 years is up. So then we get A equals 12,000 times 1 plus R over N to the NT 4 times 5. Right, now take a minute, try to plug this into your calculator. Right, now on the test you won't get a calculator, but we won't ask you problems like these where you have to find the value, right? We'll probably just ask you to set up the formula, or if we give you a calculator section, then it'll be like separate, right? We'll give you like a separate page where you can use a calculator, right? But you'll know more information about that when we get closer to the testing day. All right, so you guys can use any calculator as long as you know how to use it, at least for this section, right? We're really just doing some example problems and then you have homework as well. If you plug it into your calculator and you did everything correctly, you should end up with $13,934.21. Okay, so this is the amount that you get after 5 years at 3% compounded quarterly. If you invest $12,000. All right, so it looks like you get about, I don't know, $1,900 more than what you originally started with. Another note on calculators, I had told you guys in class, you can use Desmos, right? That is a graphing calculator, so you can plug in this exactly as you see it. I think in Desmos, if you want to multiply in the exponent, you should put parentheses around the 4 times 5. Or you can just do it, you know that that's 20, right? Or I had said that if you're going into pre-calc honors and you don't have a TI-84 graphing calculator, there is an app on the phone that mimics the screen of a TI-84, and it's Calculate 84. If you want to download this app on your phone, your iPad, it's going to look pretty much identical to what you would see if you had a physical TI-84 graphic calculator. So if you're going into pre-calc honors or pre-calc honors advanced, right, I would recommend you at least get it so that you can familiarize yourself with the controls. All right. So that's the first example. The second example, same thing. We have the same amount that we're investing, the same rate, the same amount of time. We're compounding this time monthly, right? Monthly, there's 12 months in a year. So I have n equals 12. I would go ahead and plug this into this formula. I have a equals 12,000 times 1 plus 0.03 over 12 to the 12 times 5. Right? And again, take a minute, plug this into the calculator, right? If you have a scientific, a graphing, or just use Desmos online, plug this in your calculator and you should get your accumulated value, or your future value is going to be 13,939.40, right? Something like that. All right, so notice that if you compound monthly versus if you compound quarterly, you end up making more money if you compound monthly, right? It looks like the difference is, I don't know, not much, like $5, right? So it's not that much different. So you can probably expect that if you increase the amount of times that you compound, that you'll make more money. So this is where E comes into play, right? The constant E is that if your compounds increase and you bring them towards infinity, right, you can compound every day, you can compound every hour, every minute, every second, every microsecond, right? You'll keep compounding your investment at that annual rate of 3%, and you end up at the highest amount of money that you could possibly earn, right? It's not going to go like crazy high, but you're going to see in the next page, in the next example, how much money you would get. All right, so if you do compound every single second, every microsecond, as much as you possibly can, that's called continuous, right? So a problem is going to ask, find the balance after this many years compounded continuously, right? And that's when you would use this formula, right? PE to the RT, you can remember PERT, right? For to help you remember it, right? PE to the RT, and we have these same exact values as we did in the previous problem in the other formula. We still have the same P, T, R, and A, right? And the next problem is going to give us an example of a problem where we would use continuous interest. All right, so we have the same principal value as before, right? I know 12,000 is our initial amount that we're investing. Our rate is going to be 0.03, right? Find the balance after 5 years. I know that's T. Compounded continuously is we're going to use this formula, A equals PE to the RT. All right, so I'm going to have A equals, my principal is 12,000, times E to the 0.03 times 5, right? Plug everything in. E is a button on your calculator. A lot of you have that TI-30X 2S calculator. You should see it if you click second ln, right? So second ln, right? That should be a button on there. Or there's a button that says E already. And you don't have to do second anything, right? Depending on the calculator that you have, but typically it's right with the ln. And even in the next lesson, we're going to talk about what ln is, right? But for now, you guys should know that E, to find that on the calculator, second ln. So it's going to be E to the 0.03 times 5, and then that number times 12,000 is going to get you A equals $13,942.01, right? So you can see that you get a couple dollars more if you compound continuously, right? It's not that much more, right? Compared to the value, you can check, compared to the value that you get when you compound monthly, I think it's only about $3 more, and compounded quarterly, it's about, I think, $8 more, maybe a little less. All right, but this is what you would get if you compound continuously. If you put it into, I don't know, an account that is continuously compounding, that's how much money you would get, and that's how you would answer these kinds of problems. All right, and that's it for this lesson. This is the only part where you'll need really a calculator, but again, like I said, on your test you will be given problems that you don't need a calculator, that will probably just have you set up the equation, but you'll have more information on that the closer we get.